Okay, so we are on Unit 1, and the topic is Computer Systems Overview. Okay, so the name of this module is Systems Software. From your background, having done IS, you know not by now that the general categories of software, we have application software and we have system software. We said application software is the software that we use to apply our mind, such as Microsoft Word, PowerPoint, Adobe Reader, all of those are application software, okay? We use it to perform everyday tasks. However, system software is software that we use and we run on top of it's used to control hardware. And one such example is the operating system, Linux, Android, and Windows is a very popular example. Okay, so another term that we normally use to refer to system software is operating system. Okay, so let me just take you through an introduction. So an operating system facilitates the interaction between hardware resources and the user of a computer. The purpose of operating system is to make the computer system convenient to the users. The operating system is responsible for controlling computer devices. It is very important to know the relationship between hardware resources and the operating system. Okay, so we will sort of elaborate later on in the presentation how these different layers of the computer actually interact with each other, from the hardware to the software to the operating system. So we will cover the following learning outcomes. Describe computer architecture and organization with emphasis on topics that relate to the operating system design. Demonstrate an understanding of operating system design. Explain the process of how instructions are executed with regard to processor and instruction registers, interrupt, and scheduling. And the last outcome we'll cover is to describe the various input-output communication techniques. Okay, so back to the operating system. You can see on the diagram in front of you on the right-hand side, okay, we have the different layers that actually make up the computer. We have the end user at the very top, the person who's interacting with the computer, with the software. They are sitting in front of some sort of application, okay, whether it's Microsoft Word or Microsoft PowerPoint. So below that is a layer which is the operating system, okay. Operating systems were made to bring about convenience and make it easier for users to operate a computer. Because before operating systems existed, we had to use commands. So everyone wanted to use a computer. It had to be very technical because you basically wrote a lot of code to operate the actual computer. So thanks to operating systems, now there is a graphical interface. Okay, everything is done in Wizards. You don't need to be, there's a mouse, there's a keyboard. You don't have to be a technical person to use a computer. So that layer of the operating system is actually very crucial. Okay, it was a very good invention, and then obviously the hardware. So our operating system also helps us to control our hardware, right? So we say that operating system exploits the hardware resources of one or more processors to provide a set of services to systems users. Manages secondary memory and input-output devices, okay, which we'll also elaborate later on in the presentation. So what are the basic elements of a computer? If you look at a computer, like the human body, okay, we tend to refer to this as the anatomy of the computer. There are certain vital organs that are crucial for the functions of a computer. Same like in our bodies, we have our brain, we have our heart, and we also have our blood vessels and so forth. So if you look at these components, the CPU, the system bus, the main memory, and our input-output modules, They work hand in hand and they allow us to operate the computer. Okay, the CPU is one device that actually it controls the calculations, it performs the functions for the computer. Okay, it works like the brain. We have our system bus. Our system bus, you can interpret it as a pathway at which the data travels from one component to another. Okay, our input-output modules, they're in charge of ensuring that our peripheral devices connected to our computers are able to send functions to the CPU. Okay, and then we also have our main memory, which you may have also heard of it being referred to as RAM. Okay, can I just also ask if you just notice any of your classmates joining the class that you admit them to the presentation so that I don't have to pause the class in between, please? So we're saying that these are the basic elements and they're very crucial to the functioning of a computer. The CPU does the calculations, performs the functions, the system bus, which basically it's like the road or the pathway at which the data travels, okay? Because all of these are external components. Then we also have the main memory, okay? So the main memory is like a spreadsheet with instructions, like picture it like an Excel spreadsheet where it holds all the different instructions and all the data that the CPU must perform, okay? So they work very much hand in hand, and the CPU can also be referred to as a processor, okay? It controls the operation of the computer, performs the data processing functions, referred to as the central processing unit. You will see that the CPU is actually a very important device in the computer, and itself has its own sort of diagram with its own components that help us to understand how it actually does this thing of input, process, and output. Okay, so we have inputs, which is data coming in or instructions that need to be executed, or input output devices that require a response. Okay, and they send these messages to the CPU. Okay, and there is a component within the CPU called the control unit. The control unit is like the director of the CPU. It determines which instructions get executed first. Okay, we have the memory unit, which houses all the functions and instructions that the CPU must perform. Then we have the arithmetic logic unit, or the ALU, which this component actually performs the actual calculations. It does addition, subtraction, comparison between two variables. Okay, so this is the actual component that actually does the calculations. Okay, and then we have the output. Now, the output unit comes in the form of an output device, same as how the input unit would be something like an input device, like a mouse on a computer. Okay, that's the input that's requesting a service from the CPU. The CPU does its process, and then there's an output or results that's generated. Either the generated is outputted to something like speakers or output devices. So if your input was play the song, okay, that request will be sent to the CPU, and it'll do sort of its calculations or whatever it needs to do, and then it will finish the process, send it to the output device. What is the output device? The speakers. In another instance, it could be a printer. You open up Adobe or whatever document you want to print as input. You click on the print, then the processor does its work, and then output comes from the printer. Okay, so that's the general flow in terms of input, process, and output, and you can see that the CPU is at the center of that. So this slide basically further elaborates on what we saw in this particular diagram in the previous slide. So I just skipped through it. Okay, so when we talk about main memory, which we saw in the basic elements diagram. So main memory is a separate component. Another term for it, we refer to it as RAM, or random access memory. When we think of memory, we think of something we can always recall, no matter what, we can always remember it. But in terms of computers, memory is something that is very volatile, which means it forgets, okay? And they say here that the main function of the main memory is to store data and programs. Main memory is volatile. When the computer is interrupted or turned off, the data stored is lost immediately. It is a type of memory that requires power for it to retain its content or store information. Main memory can also be called primary memory or real memory. Okay, so you need to grasp this concept that in terms of computer, memory is something that is not permanent, it is temporary. It's not the same as storage. Although we tend to use the terms interchangeably, but it's not the same thing in terms of computers. So why do we call it primary memory? Why do we give it all of these terms? Main, primary, real memory. Why? Because when the CPU is performing its function, it uses that particular memory, which is the RAM, as the main source or the primary source. Okay, it does not use the hard drive. It uses RAM as the main source. Hence, RAM is referred to as main memory or primary memory, and you say it's volatile for the mere fact that when you switch off the computer, it loses its content. Okay, in actual fact, if you take a movie, okay, you take a movie, or all the people who like to play a lot of games, gamers, a good example, you take a disc, a game you buy from the shop, you put it inside your computer. That disc is downloaded onto the computer's main memory, which is the RAM. Okay, so the gamer, the whole time they're playing the game, they're actually playing it not from the disk, but from the computer's main memory. That's why they will tell you that you have to have these minimum requirements before you can run this game. Otherwise, you're going to start to experience problems. It's going to start to lag and start to become slow. Okay, so that whole thing is downloaded onto the RAM. If the game is 4 gigs, then you need about 4 gigs of RAM. Even that is minimum. You probably need more extra, because remember, as much as you're playing the game, you still need to, your computer in the background is still performing tasks. The CPU is still using the RAM for other unrelated tasks. Okay, so you definitely need to have enough, and you notice this a lot. Why are prices of computers different at the store? Why is the one with 2 gigabytes different to the one with 4 gigabytes of RAM or main memory? It's because the one with 4 gigabytes can store more functions or more instructions for the CPU, and hence it becomes faster. Okay, so there's a lot of things we can say about main memory, but for now, the key thing that I want you guys to take out of this, that main memory can also be referred to as RAM, and it's temporary storage. It wipes its content once the computer has been switched off. Then we also have secondary memory. Okay, so secondary memory is what we call non-volatile, which means it does not lose its content when the computer is switched off. Example of this would be our flash drives. Okay, flash drives, if you switch your computer off or you eject it from the computer, it doesn't matter. Content is retained. External hard drive, same thing. DVD, ROMs. So all of those are example of secondary memory. The reason why the RAM was called primary and the hard drives and so forth are referred to as secondary memory is because when a computer is overwhelmed, okay, it has no choice but to borrow from the hard drive. So if you buy a computer that has 2 GB of RAM and the tasks you're performing require 4 GB of RAM, the computer will still execute those tasks, but you experience a lot of lags and delays in between. Okay, and the main reason for that is because you during that phase where the computer realizes that it's now really under pressure and you're executing more than what you have, it will go to the hard drive and virtualize additional memory. Okay, you will still experience problems because now the computer has to go a step further. It's keep on bouncing between the RAM, not finding what it's looking for, and going to the hard drive. Okay, so it's not to say that, oh, because secondary memory is there, it's fine, then I can settle for a system with very small RAM. That's not how it works. You're still going to experience a lot of problems. The computer is just doing that for itself, and in between that, it accepts the fact that there's going to be delays. So our input-output modules, and these are attached to our input and output devices. Okay, so very important, the mouse, the keyboard, very important in the functioning of a computer. You won't be able to use a computer as an end user without those two input-output devices. So they are modules that are assigned, okay, and they can send input-output requests directly to the CPU. The CPU will literally stop everything it's doing for those input-output modules, okay? So that's why no matter how busy your computer is, as soon as you move your cursor, the cursor will move because of the input-output modules, okay? Very important that these input-output devices take first priority. So we also have the microprocessor. It says that invention that brought about desktop and handheld computing. Processor on a single chip, fastest generation purpose processor. Each chip contains multiple processors. So a microprocessor, before processors have existed for as long as computers existed, but the computers back in the day were so big. You can imagine how big those actual processor chips were physically. So, but the capacity was very small as well. So we've moved on now. And what has happened is that technology has become more sophisticated. The devices have gotten smaller, okay? Thanks to the ability of manufacturing microprocessors. We make the processors smaller, which means the actual devices as well become smaller. That's how we have smartphones. And by the way, smartphones also have RAM, which is main memory, and a CPU inside. Okay, so thanks to the technology of microprocessing, our technologies have become smarter and smaller and more portable. So how does a CPU execute an instruction? We said the RAM holds the instruction, the CPU executes. Now, an instruction is executed in 2 stages. There's the fetch stage, then there's the execute stage. The fetch stage defines how the CPU has to fetch the work it needs to do from the RAM. Okay? Then the execute stage defines the fact that the CPU has to actually execute that instruction. So those are the 2 main stages. Okay? Now, if you see in the next slide, the instruction cycle actually gets more interesting. And so we have the control unit, the ALU, and the RAM. We saw these components when we we were talking about the diagram of the actual CPU. Okay, now we have fetch, we have execute stages, and those two stages are further divided into two phases each. Okay, so we can say the execution of an instruction by a CPU actually happens in 4 phases, 2 stages, 4 phases. Okay, so the 4 phases are, the first phase is still fetch. So what happens? It has to fetch it, obviously under fetch instruction stage. It also has to decode it. It has to break down, make sense of the data, because computers communicate in binary, okay? So it has to sort of decode the data, convert it from one form to another, okay? And then as part of the execute instruction stage, 2 phases, execute and store. So once the CPU has executed or performed the transaction, it needs to send it back to its original location, okay? To send it from that original location back to the output device, if it's through an input-output module. So you can see these phases and which part or which component of the CPU they actually occur, okay? You can see fetch, the RAM is here, so we fetch it from the RAM, we send it to the director of the CPU, which is the control unit. It decodes, it does the conversions. We send it to this ALU component, which you said it does the actual calculations, addition, subtraction, comparisons. It executes, and then it has to send it back to the RAM again. It's complete. The function is complete, back to storage. Okay, so this is how a CPU executes instructions. And we hear of all of these modern CPUs with multiple cores, which means it's one physical chip, but it has multiple cores, which means for each core that it has, it can perform multiple instructions. Okay, so if it's a dual-core processor, it means it can perform this instruction cycle, 2 of them simultaneously. It's one physical chip, but it's acting as if there were 2 chips in the particular computer. And then we have our instruction register, okay? So the instruction register is a place, an internal location within the CPU, hence the term register. It's an internal location within the CPU. So once an instruction moves from the RAM to the CPU, okay, before the ALU can even touch that instruction, it has to be registered locally with the CPU. So in other terms, we can say the registers of the CPU are a form of storage, okay? A form of storage, very small storage for the CPU to store instructions that it needs to execute, okay? And interrupts. So special hardware that operates using input-output modules are able to interrupt the CPU while it's performing its task. Because as I said earlier, input-output devices take first priority. And to visualize this, picture a mouse. No matter what you're doing, the cursor will always move, okay? That's because an interrupt is a signal. It's a signal that is sent. It's an electronic signal that is sent to the CPU to say, stop whatever you're doing and respond to me, okay? Because remember, the CPU is constantly performing transactions. So through interrupt requests, devices like keyboards and mouses, they send this interrupt signal to the CPU to say, give me first priority, leave whatever you're doing, okay? So not only is that done through input and output devices, but there are other ways at which an interrupt signal can be sent. And you'll see this in the next slide, the different classes of interrupts. We have interrupts that occur because of a program. So it says generated by some condition that occurs as a result of an instruction execution, such as arithmetic overflow, division by zero, attempt to execute an illegal machine instruction, and reference outside a user's allowed memory space. Okay, so whenever a program throws an error, because the user must see the error message now immediately, that in itself causes an interrupt or sends an interrupt signal to the CPU to say, this is an urgent matter, respond now. And generated by a timer within the processor, this allows the operating system to perform certain functions on a regular basis. So anything that involves a timer, any scheduled task, okay, as well, which would cause an interrupt signal to the CPU. And of course, input-output devices, which I did mention, and hardware failure. So if there's a failing device on your computer, okay, generated by a failure such as power failure or memory parity error. So you have a faulty component, your computer won't even function. Okay, that's immediately going to send the interrupt signal to the CPU. The memory hierarchy. It is a concept that is used to describe different ways in which a computer handles information. Memory hierarchy can be used to separate storage devices into a hierarchy depending on the response time. The hierarchy levels can be distinguished by their capacity, speed, and cost. Okay, so I'll show you just now how the memory hierarchy looks like, okay? But what you need to keep in mind is if you look at the memory hierarchy, when you go from going down from the top downwards, it's sort of like a pyramid, decreasing cost per bit as you go lower, increasing capacity, increasing access time, increasing frequency of access to the memory by the processor. Okay, let's take the second one as an example, increasing capacity, and then I'll show you how the memory hierarchy actually looks like. So we have our registers, okay? And we said the registers are a form of storage very small for the CPU to register an instruction as it's coming from the RAM. So we acknowledge that is memory, that is storage memory, okay? But the very smallest type, okay? So as we go below that, we have cache memory, okay? Now, cache memory, I will save that for part 2 of the series. Okay, remember I said this first study unit, we're going to do it in 2 parts because it's very important. So I'll save cache memory for the second part of this lecture. So it's also a form of storage, but it has also greater capacity than the registers. Then you have inboard memory or main memory. So we have our RAM. So our RAM has greater capacity than what you'd find on the cache and what you'd find on the registers. Then we have outboard storage or magnetic tapes disk, such as our all of our external storage devices, okay? Included in this could be flash drives and external hard drives and so forth, which will provide for higher capacity of storage, okay? Then you also have offline magnetic tape storage. So as you go from top to bottom of the hierarchy, what you notice is that decreasing cost per bit, increasing capacity in terms of storage, increasing access time, decreasing frequency of access to the memory by the processor, okay? So I'll also, not to overwhelm you, I'll also save the different types of registers for the second part, the next time I see you, the second part of the lecture of Unit 1. But for now, the important thing that you take out of this is that you know what registers are. They're a form of storage for the CPU. Okay, so in conclusion, this study unit gives detailed information about the basic elements of a computer, which are processor, main memory, input-output modules, and the system bus. We covered instruction execution, processor memory, processor and input-output. We covered interrupt and interrupt processing, and we also covered the memory hierarchy. So in the second part of this lecture, we're focusing a lot on the different types of registers, okay, CPU registers. We're focusing a lot as well on cache memory, as well as multiprocessor versus multi-core concept, and also the different communication methods that can be initiated by our input and output devices, such as our IRQ request and our DMA request, okay? So I would now provide an opportunity for you all to ask questions regarding system software.